Let's move on to the next question of this paper, that is question number 4. The sum of all two-digit positive numbers which when divided by 7 yields 2 or 5 as remainder. So let's start the simple question of PNC. Two-digit numbers when divided by 7 yields 2 or 5. First two-digit number which will give you remainder as 2 is 16. So when you divide by 7 you find 16, then 23, then 30 and so on. This point is clear. And what would be the last number? Last number when you divide next say 91 plus 2, that is 93. That's the last two-digit number, right? Now when you divide by 7 and the remainder is 5, two-digit number, then clearly first number is 12 because 7 plus 5 is 12, then 19, then 26 and so on. And what would be the last number when you divide? This would be 96. Here you can clearly see in the first case there are 12 such terms and here there are 13 such terms and there is nothing common between the two. So the sum of all these numbers when we find, therefore the required result is equal to 12 by 2 into a plus l, that is 16 plus 93, or it is giving us 109 plus 13 by 2 multiplied with 12 plus 96, or you can directly say it is 108. So the result we are getting over here is 6 into 109 plus 13 into 54. Just add the two, simplify to get the result simply as 1356. Let's see whether it is available here in the options. Yes, the correct answer from this one is option number 2. So let's mark and mention as the correct answer. I'm sure this question is clear. Let's move on to the next one, that is question number 5. If dy by dx plus 3 by cos square x into y equals 1 by cos square x, x is in the interval minus pi by 3 to pi by 3. Also initial value condition is given for y at pi by 4. We have to find y at minus pi by 4. In one go it looks like this is linear differential equation, but when you see the term 3 by cos square x and 1 by cos square x, it is simply variable separable at this stage itself. So let's start with this question. It says dy by dx is equal to, taking this term on the right hand side, we can see 1 by cos square x, that is sec square x is common, and we are left with 1 minus 3y. So sec square x into 1 minus 3y. Just cross multiply the term of y towards dy and term of x with dx. We have dy upon 1 minus 3y. This gives us log mod 1 minus 3y divided by minus 3 is equal to integral of sec square x, that is tan x plus constant of integration. Now it is given at x equals pi by 4, y is 4 by 3. So put x equals pi by 4 and y as 4 by 3. Log, here when you put 4 by 3, what you obtain? Simply 1 minus 4, that is minus 3. Inside the mod it becomes simply log 3 upon minus 3 is equal to 1 plus c. Therefore, when you find the value of c and put it back, you have log mod 1 minus 3y divided by minus 3 is equal to tan x plus c was there, and what is c? c is minus 1 minus log 3 divided by 3. So this point is clear. C is minus 1 minus log 3 by 3. Correct? Now you need the value at x equals minus pi by 4. Now put the value here at x equals minus pi by 4. Let's see what is the result. Log 1 minus 3y inside the mod sign divided by minus 3 is equal to minus 1 minus log 3 divided by 3, or log mod 1 minus 3y is equal to, this minus 3 goes to the other side, making it 6 plus log 3. I am sure this is clear. Mod 1 minus 3y is equal to 3 e to the power 6. From here we have 1 minus 3y is equal to plus minus 3 e to the power 6, or simply y equals 1 minus plus 3 e to the power 6 divided by 3. Now let's look at the given options. We can see 1 by 3 plus e to the power 6, 1 by 3 plus e to the power 3, and so on terms are there. Looking here, 1 by 3 minus plus e to the power 6 is the result. So 1 by 3 plus e to the power 6 is the correct answer. So mention as the right answer option number 1. I am sure this is clear. Let's move on to the question number 6. Consider a triangular plot ABC with sides AB 7, BC 5 and CA 6. A vertical lamppost at the midpoint D of AC subtends an angle 30 degree at B. The height of lamppost is, a question from trigonometry. So let's first plan the geometry part, what they are asking for. They are saying there is a triangle. So let's draw a triangular park like this. It is mentioned that lamppost is at the midpoint D of AC. So mark here in this fashion like A, B and C. Now say here is the midpoint D and you have to make a lamppost over here. Let's make it like this. Correct? Next, when you join this midpoint with B and also B with the head, that is top of the lamppost, you can mark here the points like D and say here L. Mention that this angle is 30 degree. Correct? This is the total data given to us. Now mentioned here this angle is 30 degree. Okay. So this is the total data given to us. Now also mentioned AB, BC, CA the lengths. Let's mention these things as well. This is 7, this is 5, the total length is 6. So we can write here 3 and 3. We can apply Apollonius theorem to get the length of median BD. This is clear. So let's start this question. We have the result twice of BD square plus AC by 2 whole square is equal to BA square plus BC square, BA square plus BC square. Substitute the values in this equation, we get twice of BD, this is something we have to find, twice of BD square plus AC by 2, that is 3 square, that is 9, is equal to BA square, that is 49 plus then next is 25. Simplify this result to get the value for BD square. Now we can see 49 plus 25, that is 74, minus 18, that gives you 56, by 2 mean 28. So from here we get the length of median as 2 root 7. I am sure this part is clear. Next we have to find the length of lamppost DL, right? So DL we can simply find using trigonometry further. Therefore DL by BD is equal to tan 30 degree, right? So from here we get the value DL, that is the length of lamppost, is equal to BD into tan 30. BD is 2 root 7, tan 30 is 1 by root 3. So result is 2 root 7 upon root 3. Let's check out the result. Options include denominator rationalized. So when you multiply and divide here by root 3, you can see this becomes 2 root 21 by 3. Yes, this option is available, 2 root 21 by 3 as option number 3. So let's mark and mention the correct answer as third option. I'm sure this part is clear. Let's move on to the next one.